In this lesson, you will learn about functions and key features of functions. We will first learn to identify these 7 different types of functions, and then we will specifically look at parabola key features, which is the graph of a quadratic function. So we will talk about those key features of a parabola. Our first function we're going to look at is linear. The parent function of a linear graph is y equal x. Notice our graph, it makes a line, it passes through the origin, it has a slope of 1. So a parent function is just the function that has no transformations occurring. It's just the basic function, the starting parent. The domain of this function is all real numbers, or we could use interval notation, which is negative infinity to infinity. The domain stands for your x values. So this graph goes from negative infinity all the way to positive infinity and will touch every x value on the graph. The range is also all real numbers, or negative infinity to infinity, because again, every y value on our graph will be reached by this linear function. Some other examples of linear functions, we have y equals 4x plus 2, y equals negative 1/3 x minus 1, and y equals negative 3x. Notice all of our graphs of these functions make lines, meaning they are linear functions. Let's look at the next type of function. This is going to be a quadratic function. We will focus on quadratics for the majority of Math 2. The parent function of a quadratic is y equals x squared. Again, meaning there's no transformation. That's the basic starting function. So a quadratic function makes a U shape, and this U shape is actually called a parabola. The domain of this function is from negative infinity to infinity. This graph will continue on and on and on and touch every single x value from negative infinity to infinity. The range, we use the bracket because it's starting at 0. Now, if it didn't touch 0, we would use a parentheses. But the bracket means it is touching 0, that is our lowest y value, and it's going off into infinity on the y-axis. Some other examples of quadratic functions, y equals x squared plus 2x minus 3. This is a function in standard form. We also have y equals negative x minus 2 squared plus 1. This is what's called vertex form. And then finally, y equals x plus 1 times x plus 3. This is called factored form or intercept form, and we will look at all 3 of these forms in more details throughout this unit. Notice the graphs of each of these functions. They do make the parabola U shape. Let's look at our next type of function. It is an exponential function. The parent function is y equals, we'll have a base raised to an x power. So here we have y equals 2 raised to an x. Exponential, you have the x in the exponent. Notice the graph. Exponential functions will grow very, very quickly or get small very, very quickly. The domain of this function is from negative infinity to infinity. Here on our x-axis, every point will eventually be reached by this function. The range, the y values, notice we use a parentheses for the 0. This exponential function actually will never reach 0. It gets very, very close to 0, but it never reaches it. So we use a parentheses for the 0 to infinity for our y values. Some other examples of exponential functions, we see the different types of functions and what that causes the graph to do. Sometimes it will flip over the x-axis, meaning a reflection. It can also cause the graph to decay rather than growing. Exponential functions can grow or get very, very small. Our next function that we'll want to look at is an absolute value function. Recall the definition of absolute value is the distance from zero. So in this case, we have this V shape, and the parent function is y equals just the absolute value of x. So this V shape represents that absolute value function. So if we wanted to know like the absolute value of 3, that will give us a 3 because it's the distance from 0. But even true for a negative, the absolute value of a negative 3 is 3 because, again, it's the distance from 0. Our domain of this function is from negative infinity to infinity. And our range, we are going to have a point here at 0, and it shoots off into infinity for those y values. Notice some other examples. With these different examples, yes, the graph can transform. So depending on how the equation is set up, will represent how the graph will look on the coordinate plane. But all of those do make the V shape for absolute value. You've got the V in the name. They make the V shape. Square root function. The parent function will have a square root symbol. So of course, for a square root function, it has the square root symbol. And notice that this is kind of just of a half of a U shape. So if you'll remember our parabolas, the U shape that we saw earlier, if you turn it sideways, we just have half of that here for the square root function. And that is because squaring that we have in a quadratic and square root that we have here, those are opposite operations. If you've ever typed in your calculator the square root of a negative number, it gives you an error. That's why we don't see the full U shape here for square root, because those are errors and they actually result in imaginary numbers. The domain of this function is not all real numbers. Notice it actually starts here at 0. We do have a point, so we'll use a bracket, and then it goes off into infinity. Our range is also from 0 to infinity because, again, there is a point there. We have a bracket to include that 0 and then off to infinity for the y values. Here's some other examples of our square root functions. Notice each time it just kind of has that line off to one side to represent the square root. It's not going to be a full U shape. It's just partial curve of that square root function. Our next function is a cubic function. The parent function is y equals x to the third, or cubed, x cubed, and it makes this curved type of graph. The domain of this graph is from negative infinity to infinity, as well as the range. Every x value will be reached, every y value will be reached. Some other examples of the cubic function, again, it makes this little curved line, and that would be a cubic function. And then finally, we have our cube root function. Notice our cube function from before is now rotated because they're opposite operations. A cube root is the opposite of cubing. So here we have our function y equals the cube root of x. And that's how come it turns on its side here, because it's the opposite operation of our previous function. Here we'll see the domain and our range once again being negative infinity to infinity. And then some other examples to still see that cube root function, even with its transformation moved around the graph, we still see that curve turned up on its side. So now let's talk about specifically quadratic functions. They are going to be our key focus in Math 2. The name of the graph of a quadratic function is called a parabola. So we're going to identify some parabola key features: the vertex, axis of symmetry, x-intercepts, and y-intercepts. So first, our vertex. It's the point at which the function goes from increasing to decreasing or vice versa, the maximum or minimum point of the function. So here we have an example of a quadratic function. This parabola is a U shape. So the point at which the function goes from increasing to decreasing or the other way. So here's that place where it's changing from increasing to decreasing. That point is called our vertex. This point will either be a maximum or minimum for each of the graphs. In this one, it is a minimum. It's the lowest point on the graph. The axis of symmetry is the line that passes through the vertex, and it's the line of reflection or line of symmetry. So here, this line, it will always pass through the vertex. That is called our axis of symmetry line. It's the line that cuts the parabola symmetrically down the middle. Our x-intercepts are points on our graph at which the graph crosses or touches the x-axis. They are also known as zeros or roots. So if you're asked for the zeros of a function, you would look at the x-intercepts. If you're looking for the roots of a function, you would look at the x-intercepts. So where it crosses the x-axis, those could also be called your zeros or roots. For a parabola, you could have 1, 2, or no x-intercepts, and we'll look at that in more detail here later. Y-intercept is the point at which it crosses the y-axis. So the y-intercept, here where it crosses the y-axis, and kind of a nice little thing to remember if you're having a parabola. If you have a quadratic function in standard form, the c value is the same as your y-intercept. So good thing to know there as you're working with quadratic functions and their graphs of the parabolas. So let's specifically look at some vertex points. We said that it could be a maximum or minimum. So notice if the graph opens up or if the graph opens down, that's going to affect that vertex being the highest or lowest point. We can use our happy faces and sad faces here. So when the parabola opens up, the vertex is the lowest point. So we're going to call that a minimum. This is going to happen anytime your a value is positive. You're going to have the lowest point on the graph is the vertex, and that's going to cause a minimum. This graph has a minimum at 2 because that's the lowest y value that this graph reaches. So when the graph is turned upside down, the vertex is the highest point or the maximum. And this will always be true when a is a negative, we will have a maximum. But notice the maximum value, again, here is 2. That's the highest point on the graph that it reached. So your maximum value does not have to be positive or negative. It's the a value when they're in standard form or vertex form. That a value at the beginning of your function will help determine if it opens up or down. X-intercepts, they could also be called zeros or roots. we could have 1, 2, or none. So let's look at some examples of that. When our graph has one x-intercept, so whether that's opening up or opening down, that would have 1, 0, or 1 root, or even 1 x-intercept. The graph could also cross at 2 points, so that would have 2 zeros, or intercepts, or roots. It can be called any of those names. And then finally, it is possible for these parabolas to have no x-intercepts. Be careful not to confuse it with y-intercepts. A graph will always have a y-intercept for a parabola, but it is possible to not have an x-intercept depending on where that graph is. If it opens up above the x-axis or even opens down below the x-axis, it is possible to have no x-intercepts. So let's look at an example to name these different key features. A vertex, remember, that is just one point, and that is an xy ordered pair for this graph at 2, -1. So beginning from the origin, we're going to count x and then y, and we get to that point, 2, -1. Remember, the axis symmetry is going to be an equation that cuts through the vertex. So x equals 2, wherever your vertex is, find the line that would go through that point. Notice also that the x of your axis of symmetry is the same as the x of the vertex. The x-intercept, or roots, or zeros, whatever name they want to call it, that would be 2 points for this graph because we cross here at 1, 0, and we cross here at 3, 0. Be especially careful when you name your ordered pairs. An x-intercept will always have a y value of 0. Don't flip-flop your ordered pairs and call it 0, 1. That would be on the y-axis, which is our next thing to notice is our y-intercept. Y-intercept will always be 1 point. We have 0, 3 for that point. Again, just like x-intercepts, you have to be careful where you put the 0. Same for y-intercepts. For a y-intercept, your x value will always be 0. Let's look at our next example. Go ahead and pause the video and try it on your own before we talk about it. For the vertex, we should find 1 point at -1, 9. The axis symmetry is an equation, x equals -1. The x-intercepts are 2 points. We have -4, 0, and 2, 0. And then finally, our y-intercept is 1 point at 0, 8.